Dear students, now we will move on to the first ever physical chapter relative to the class 12, that is second PUC, that is the solid state. Okay. So I think in the first year, I think class 11, we have studied preferably the states of matter in the form of the gaseous, along with a little bit of which one? The liquid also, where it comprises of only the surface tension and then the viscosity with respect to liquid along with its vapor pressure also. So that much of concept that we have studied in the liquid concept as a state of matter, but we have studied about the gaseous. Okay. So now we will move on to the another important state of matter, that is called as the solid state. Okay. So this usually comprises of 7 marks as for the PU board is concerned. So that can be split as 5 plus 2, means 2 marks of one portion and 5 marks of one portion. So usually that 5 marks can be split usually in the form of either 3 plus 2 or it may be sometimes 3 plus 1 plus 1. Okay. So that is a allotment of marks that has been preferred with respect to the solid state. Okay. Now, what a matter is, as if we know that chemistry itself a branch of science that can delve with the study of which one? The matter. So the matter, we know that occupying a definite space and having the occupying a definite volume, or it may be the size, we are calling that as which one? The matter. So that matter, which is a main concept behind the study of any part of chemistry, is comprised of, or it has been classified first on the basis of the components that has been present. Means that particular matter is majorly classified as the substance and then the mixtures, where that particular substance can be further classified as either the element or it may be the compound. Suppose a substance which is made up of only one type of its atoms, then it is considered to be the what? An element. As for the periodic table is concerned, we are having nearly 118 elements in the modern periodic table. Suppose if the same chemical substance which is made up of at least 2 or more different types of its atoms, then that considered to be the which one? The compound. The mixture now, that is the same substance as if we are mentioning. The substance which comprises of 2 or more different components. On mixing, they can appear in either in the single phase or it may be the multiple phases. They can be named in the form of respectively called as homogeneous mixture and then the heterogeneous mixture. Mixture means the 2 or more different components appear to be in a single phase or single physical state, then it is considered to be the homogeneous mixture. If it appears to be in at least 2 different physical state or the phases, then it is called as the heterogeneous mixture. Okay. So that all we have discussed with respect to some basic concepts of chemistry in the class 11, that is the first PUC, about the classification of the matter on that basis. But in terms of particle arrangement, the same matter has been broadly classified under 5 different states: solid state, liquid state, gaseous state, plasma state, and then the recent now that is found to be the Bose-Einstein condensate, or it may be the particle also. Bose-Einstein condensate we are calling it. Okay. Usually among the 5 we are majorly concentrating on the 3 because that usually depends upon the arrangement of the particles, because these are usually the intermediate states we are calling usually, of course. But as far the strict arrangement is concerned, we are concentrating on the liquid, solid and then the gas. So now, as if the very simple definition means, if the particles are freely moving, then it is considered to be the which one? The gaseous state. If the particles are loosely bounded, then it is considered to be a liquid. Whereas the same physical state in which the particles are closely and compactly arrangement, that refers to the which state? The solid state. Therefore, how to define a solid here? Solid is a what? Solid it is a physical state of matter. It's one of the physical state of matter where the particles are how and how arranged? Closely and compactly arranged. Compactly arranged. Close means usually one particle is almost touching with respect to the another. And compact means the space availability that between the two arrangement of the particles is going to be almost zero, or we can say that it is very, very less or nearly equal to zero. That is called as a compactness. And that compactness makes the solid state to be higher rigidity also. Because solids are highly rigid in nature. Why? Because they can't change their positions. As if their positions are eagerly fixed or they are regularly fixed. That is why they doesn't have the movement. Of course, even though there are some movement here, but the thing is, they doesn't changes its position with respect to it doesn't move with respect to its mean position, or it is also called as average position. That is why we are using the word considered to be the which one? The rigid. Therefore, how to define that particular state here? Solid is one of the physical state of a matter wherein the particles are how and how arranged? Closely and compactly arranged with higher rigidity also. With higher rigidity. Usually, these particles may be either in the form of atoms, molecules, ions. In some cases, it is a very rare cases that may be also in the form of which one? The free radicals. Okay, so that may be a free radicals, atom or molecules, or it may be the ions, or it may be the free radicals. Those particles which are closely and compactly arranged with respect to its higher rigidity, then that particular state of matter or the physical state of matter is considered to be the which one? The solid. Okay, so let's have what are the various characteristics of this particular solid. What are the characteristic features with respect to this one? Particles are how and how arranged? Closely and compactly arranged. How and how arranged they are? They are found to be there closely and then the compactly arranged. Then solids have higher rigidity, means that doesn't have its movement with respect to the mean position of that particular arrangement. That is why the word is found to be the what? Rigid. Okay. Then the particles are found to have the solids are found to be the particles of solid. The particles of the solids are usually incompressible. Means they cannot be further compressed. The gas can be easily compressed. Why? Because the particles are very far apart, such that I can allow those particles to come as closer as possible. As closer as possible. That is, we need some compression only by applying the what? Pressure. Even in case of the liquids also, liquids will have some little bit of which one? Compression also. Why? Because again the particles are loosely bonded. But as if the solids will have the very close and then the compact arrangement, usually we will have the zero compressibility, or indirectly it is called as incompressible in nature, or sometimes if it is a amorphous, there is a chance with respect to some compressibility here, or very least compressibility is also possible if and only if the substance is going to be the what? Amorphous solids. But with respect to the crystalline solids, it is strictly what? Zero compressibility usually. Means they cannot be further compressed. Means they are having an incompressible nature, or if it is having a less, means that is usually in case of which one? The solids. Sorry, amorphous solids. Then intermolecular forces are very strong Intermolecular forces are what? Very strong. Why? As if they are very close to each other. The net intermolecular forces of attraction between the two adjacent particles is going to be very, very strong. Means they are having a strong intermolecular bonding. Okay? Then, intermolecular distance is least. As if the particles are very close to each other. Means what is the meaning of that? The distance between the two intermolecules, or the distance between the two adjacent molecules is going to be what? Very, very less, or it may be the least. Usually in case of the chemical bonding, we are calling that in the form of usually the bond length. It's the distance between the centers of the nuclei of the two combining atoms or the adjacent atoms. We are calling that as a what length? The bond length. That is, intermolecular forces is going to be the, intermolecular distance is going to be what? Very, very least now. Then, solids have higher density. Why the solids will have the highest density here? Because their mass is exactly known. But as if the distance between them is going to be very, very less, means the volume occupation by that molecules or the particles is going to be less. We know that density is equal to mass by volume. As the volume gets a decrease, means automatically what gets increased here? The density. Therefore, solids preferably will have the what density? Higher density. The particles of solids have only the vibrational motion at the mean positions, or it is also called as the fixed positions. Usually, we are having the three different types of moments with respect to a chemical substance: rotational motion, translational motion, and then the vibrational motion. But as if the particles are highly rigid in nature with respect to solid, with respect to their mean positions, or it is also called as the average positions, they means the particles of the solids will have only the what motion? Only the what here? The vibrational motion at their what positions only? Fixed positions, or it is also called as the average positions. Okay? Then, the particles of solids have zero or sometimes less diffusibility. Zero or less diffusibility. Usually, diffusion means the movement or the flow of the particles from the region of its higher concentration to the lower concentration. Suppose if the same thing, if through the semi-permeable membrane, is called as osmosis. As in case of gases, we know that the particles are very free to move. Therefore, we can expect the movement of the particles from the region of higher concentration to the lower concentration. That is why the gases will have the highest diffusion first. And little bit next is, less is in case of the liquids. As if the particles of the solids will have the very close and compact arrangement. Usually the particles are not free to move. That is why they are having the what? Zero compressibility. Zero which one? Diffusibility, or sometimes in case of the exceptional cases, usually in case of the amorphous solids, they are having a little bit of movement. That movement is considered to be the what? Diffusion. Usually where the movement will take place from the region of higher concentration to the lower concentration. Then solids have the definite shape, size, and then the definite mass. Why? As if the particles are very close and compact, means they can have the definite shape, but little bit one of the not exact characteristic, because in case of amorphous, it doesn't have an exact shape also. So that is why generally solids will have the definite shape, and then the size along with it is having a definite mass and occupies a definite volume also. Which one? The definite volume. Means, why they are having a definite volume means because the particles are very close and compact, and they can have the definite volume. That with the volume is going to be the less, and the mass with respect to those particle arrangement is going to be the higher. Therefore, they are having the highest which one? Density. So what we can have, these are the characteristic features with respect to which one? The solid. The first one is the particles are how arranged? They are closely and compactly arranged. Okay, so due to that, these particles of solids will have the higher rigidity, means that doesn't change its position, or that doesn't move, means that doesn't change its movement, means the particles of that particular solids are highly what in nature? Rigid nature. Then, as if the particles are again very close and compact, means what we can decide? It is going to be the what? It is non-compressible, or it is having some less compressibility factor also if it is having a what? Amorphous nature. But usually the perfect solids will have the what? Incompressible or the non-compressible nature, whereas some little bit of the pseudo solids, usually the amorphous solids will have some less compression. Okay, then as if the particles are very close to each other, means the intermolecular distance is going to be very least. As if the intermolecular distance is going to be very least, means indirectly it is saying that the intermolecular forces of attraction is going to be the what? Strong. Usually the attractive force I am mentioning here. Intermolecular force of attraction is going to be very strong in case of the which one? The solids. Then these particles will have the what density? Highest density. Why it is having a definite highest density? Let's observe the ninth one. That is, the solids will have the what? First, they will have a definite size, definite shape, definite mass, and also it is having a definite volume. As if the particles are very close and compact, means the mass with respect to that one is going to be the higher, with occupying the less volume. Therefore, higher the mass and lesser the volume, means it is indirectly having the highest what? Density. Then, as if we know that the particles of a system will have the three different types of motion called as translational, vibrational, and then the rotational. As if the solids will have the higher rigidity, they can have only the vibrational motion at their what positions? Mean positions, or it is also called as average positions. And finally, we will decide these particles of the solids will have the zero, or sometimes it is the less diffusibility. As if the same reason, as if the particles are very close and compactly arranged, means they can have the no movement. No movement means usually we are calling that as a zero diffusion is possible from the region of higher concentration to the lower concentration. In few an exception case of the amorphous solids, we can have some less diffusibility also. So what these are? These are considered to be the what? Characteristic features with respect to which one? The solids. Then types of solids. Types of solids. Based on the arrangement of particles, arrangement of closely and compactly, these solids can be of two types. No doubt they are having a close and a compact arrangement. That considered to be the which one? Solids. Again, based on that particular arrangement of how they are arranged. Even though it is closely and compactly, they are to be around two different nature. So one is crystalline solids. The second one is amorphous solids. Amorphous solids. First, what are solids? Solids itself is a physical state of matter wherein the particles are how and how arranged, closely and compactly arranged with a higher rigidity. Even with higher rigidity, with the same which close and compact arrangement. If it is found to be the regular arrangement, then it is found to be the crystalline solids. If it is found to be the irregular arrangement of the same, means it is found to be the what? Amorphous. Means solids having a definite arrangement of its particles, then it is found to be the what? Crystalline solids. Whereas the same solids having definite arrangement or having no definite arrangement of its particles, then it is considered to be the which one? Amorphous solids. Because this is derived from a letter called as amorphia, means amoeba. It is referring to a living species in the form of which one? Amoeba. Amoeba means, amoebos means it is called as shapeless. Why does it have a shapeless? Means it doesn't have the regular arrangement of its which one? Particles. Okay. Sucrose, glucose, rock salt, potassium bromide, glass, it is glass, etc. All these are the examples with respect to which one? The crystalline solids. Cellulose, starch, benzoic acid, what these are? They are the examples. Plastics, they are the examples with respect to which one? The amorphous solids. Okay, so now we will have the distinction, or it is also called as indirectly the differences between which and which? The crystalline solids and then the amorphous solids. Let's have the differences list between these two. The solids in which the particles arrangements are how arranged? Closely and compactly arrangement with a regular, it is considered to be the crystalline solids, whereas the same solids which is having the close compactness with the irregular arrangement of its particles refers to a amorphous solids. Okay, so let us have the differences between these two now. Let's have the clear differences between let's have the two crystalline solids, and here it is amorphous solids. So what we can have the major difference related to that? The particles are regularly arranged. How arranged they are? They are regular arranged. But here, the particles are irregularly arranged. But the thing is, in both the cases, they are found to be the compact and closed with higher rigidity. Both are same. But the thing is, if the closed, compact, or rigid arrangement, if it is found to be the regular, means it refers to crystalline. If it is having the irregular arrangement, that refers to which one? An amorphous. Okay. So that is why this is having a definite geometrical shape. So here, no definite geometrical shape. Again the same reason. Why? Because the particles, if they are found to be the regular arrangement, it is considered to be the what? Having the definite geometrical shape. As if the particle arrangement is found to be the irregular, means that is why they are found to be the what in nature? The no definite with respect to amorphous solids. Sharp melting point. So this is having range of melting point, or indirectly no sharp melting point. As if the particles are how arranged? Closely and compactly arrangement with the regular. All the bond distance are found to be same. Indirectly bond length we are also calling. So as if the bond length or the bond distance between the two adjacent particles in case of the crystalline solids are found to be equidistant. The temperature that has been required to break that particular bond is found to be equal in all the cases. That is why we are expecting the sharp melting point. But in the same case, of course, even though it is a solid, but due to the irregular arrangement of its particles, due to the what arrangement? Irregular arrangement of its particles, what happens there? The distance between the two particles or the adjacent particles with respect to the arrangement in the amorphous solids are found to be different. That is why it doesn't have the definite, or it may be the sharp melting point. Means it is having some range. Suppose if X is a crystalline solid, it is having a melting point of, for example, 116 or 17 degrees Celsius. If Y is an example for a amorphous solids, its melting point is between 123 to 125 degrees Celsius. So why it is due to? It is a fixed. Why? Because all the distances or the bond distances are going to be what? Same. Because of the what arrangement? Regular arrangement. But this case, as if the arrangement is not so perfect. That is why we can say that it is having some range. That is, the bond distance between the two adjacent particles are found to be quite different. Therefore, we can take the average of that one. That is why it doesn't have the sharp melting point. Or if I take an exactness, it is the range of which point? Melting point. Okay. Next. So these are found to be the true solids. It is also called as perfect solids. These are called as pseudo solids. Why the crystalline solids are found to be the which one? The perfect solids are the true solids. Why? Because what they are having? The regular arrangement. That is why they are the best examples for what? Perfect solids. True solids are also called perfect solids, are nothing but the crystalline solids. But here, as if there is no regular arrangement of the close packing arrangement of that particular atoms or the particles, they are not considered to be the which one? The pseudo solids. They can also be considered to be the super cooled liquids also, with higher viscosity also. With higher which one? Viscosity also. The measurement of thickness of a fluid or the liquid is considered to be the which one? The viscosity. As if the particles are not so close and compact, the particles are not regularly and closely and compactly arranged, means indirectly it is the supercooling nature of the liquid. That arrangement is indirectly called as what? The supercooling nature of the liquid. That makes to be the higher viscosity in nature. That is why they are not examples for the which one? The perfect. Perfect means they are not perfect, means they are considered to be the what solids? The pseudo solids. Then these are anisotropic. These are isotropic. What and what? They are anisotropic and those are isotropic. What's the meaning of isotropy and anisotropy here? Iso means same. Tropos means properties. The property of a system which gives the similar in all the possible directions. Usually some of the electrical properties are maybe the mechanical strength. Electrical properties may be in the form of refractive index and so on, whatever it may be. If they are found to be what in nature? If they are found to be what? Same in all the directions. If I measure the electrical property or the mechanical strength in all the possible directions, if it is found to be the same, means then it is considered to be the what in nature? The amorphous. Suppose if the same property of a system in which it is found to be different in different directions when we measure, then that particular type is considered to be the what? Anisotropic. Different, same in all the possible directions is called as, same physical property in all the possible directions is called as amorphous. Amorphous means they are found to be what in nature? Isotropic. But here it is found to be the anisotropic. So let us have an example. Just I will write only the rough diagram. Let us take A plus B minus, A plus B minus, A plus B minus, A plus B minus. So here is an example for an ionic crystal. For example, AB, which can have the particles of cation in the form of A plus and the anion in the form of which one? B minus. So after A plus it is B minus after it is A plus after B minus after it is A plus, means there is a regular arrangement of its particles. Okay? Suppose if I allow the light to pass through it in one direction like this, it is showing an electrical conductivity, for example, X. It is showing an electrical conductivity of which one? X. Suppose if I pass the electrical conductivity in this direction, it is showing an electrical property of, for example, Y. If it is in this direction, it is found to be the, for example, Z. Yx is not equal to Y is not equal to Z here, because if I pass the light through this one, A, the light ray that has been first appeared on the surface of A plus, then emerges into the B minus, then to the A plus, and then that is the light is moving in the direction of A plus, B minus, A plus, B minus, A plus, B minus, and so on. So that shows an electrical property. I don't know the value, let it be, for example, X. Suppose if I turn the light and if I allow the light to pass through it in this direction, for example, The first ray will pass on the surface of which one? B minus. Then it on to enter into the B minus. Then it also enter into the B minus. Means whether the electrical property that has been obtained in what the direction along the x is found to be the same or found to be the different here. It is the different. That is why it shows an electrical conductivity of which one? Y. Suppose if I tilt like this and I allow the light to pass through it in this direction. After the light will ray will pass on A plus and then to the A plus and then to the A plus. What that? It is not equal to x. It is not equal to y. Therefore, it is a different, and that is found to be the what? Means, what is electrical conductivity as a physical property that I have observed? When I measure that particular system or the crystalline solid in the different directions, the values are found to be the what? Different. If the values of those physical properties are found to be different in different directions, means it is found to be the what in nature? Anisotropic. But here, as if there is no regular arrangement of the particles with respect to the amorphous solids. If I measure the electrical property or the mechanical strength in any other directions, what happens? It is found to be the average we are calling, or it is indirectly, it is same in all the possible directions that we are measuring. That is why the amorphous solids are found to be what in nature? Isotropic. First you make it very clear what is isotropy and what is non-isotropy. It is a property of a system where the physical properties, not all the physical properties, some of the physical properties like electrical conductivity, refractive index, mechanical strength, all these, they are found to be same. In all the possible directions when we are measuring, then it is found to be the isotropic. If the properties of those are found to be different in different directions, then we are measuring, means it is called as what? The anisotropic. So that is a major difference related to the which and which, the crystalline and then the amorphous. Okay. There, after anisotropic and isotropic, then what they are having? They will get the regular surface on breakage. Breakage is also called as cleavage. But here, no regular surface on cleavage. If I cut a crystalline solid, I am getting a regular surface. Why? Because I have mentioned all the distances, that is called as a bond distance between the two adjacent particles, are found to be what? Same. Means if I cut in any directions, what happens? We are getting the regular surface on breakage. But as if the distance or the bond distance between the two adjacent particles with respect to the amorphous solids are found to be different, we can't get the exact surface. Means there is no regular surface on breakage, or it may be the cleavage. Okay. It is having a shining surface. Here, no shining surface. Again the same. Because of the regularity in the arrangement of the particles, if they are observed, means we can say that it is having that what? Regular surface, or it is having the shining surface, whereas there is no shining surface with respect to the which one? The amorphous solids. Definite delta H of fusion. No definite delta H of fusion. What is enthalpy of fusion? Delta H fusion is called as enthalpy of fusion. What is enthalpy of fusion? It is the amount of heat absorbed. Amount of heat absorbed when 1 mole of a solid changes into its molten state at what point? Fusion point, or it is also called as melting point. Means I am taking the solid substance. What happens when I heat? It starts to melt. What is the amount of heat that has been required or absorbed by how much mole of substance? 1 mole of a solid substance is called as enthalpy of fusion. The enthalpy of fusion. Okay. So here, this is having the definite enthalpy. Again, the same reason. Why? Because of the what arrangement? Regularity in the arrangement of this one, all the bond distance are found to be same, means it is having the definite what fusion? Enthalpy of fusion. The same reason. As if the particles are irregularly arranged, the bond distance between the adjacent particles are found to be different. That is why there is no definite which one? Enthalpy of fusion. So here possesses symmetry of elements. So here it possesses No symmetry of elements. Symmetry of its what? Elements. The same reason. Symmetry means regular. As if the particles are regularly arranged. If I observe in any directions, it is not the measurement of a property, just the observation of the particles in any direction. If it is going to be same, means it is called as symmetry of the elements. But as if the particles are irregularly arranged, if I observe from one direction to the another direction, what happens there? There is no symmetry observed in case of the arrangement of the elements, or it may be the particles. So what we can say that these are the differences between a which and a which, the amorphous solids and then the which one? Crystalline solids. The first one is what amorphous solids are, crystalline solids are, the particles are regularly arranged, whereas the particles are irregularly arranged in case of amorphous solids. Then, due to the regularity in the arrangement of the particles, they possesses the definite what shape? Geometrical shape. Due to the irregular arrangement of these particles, they doesn't have any definite geometrical shape. Okay. Then, same due to the equidistance or the particles arrangement as want to be regular, means they can have the sharp melting point. But due to the irregular arrangement, we can say that there is no sharp melting point in case of the water solids, amorphous solids. Then, as if the particles are how arranged? Regularly and compactly arrangement, they are found to be the true solids, or sometimes it may be also referred to as what? The perfect solids. But those are imperfect solids. Imperfect solids means they are pseudo solids. Why they are called as pseudo means? Pseudo means it is false. But usually solids refers to the regular arrangement or the compact arrangement. The irregular arrangement of the particles makes that particular solids as found to be the pseudo solids, which are also called as false solids, and sometimes they can also be converted as, or they can also be called as, they are the super cooling nature of the liquids, or it is also called as super cooled liquids, which is having a higher which one? Viscosity. Okay. So then, a regular surface on which one? Cleavage. Means if I cut that particular crystalline solids, what happens? We are getting the regular surface. Why we are getting the regular surface? Means because the arrangement is regular. But there is no regular surface when I break that, when I cleave that particular amorphous solids. Then they are having a regular arrangement, means they can have the shining surface. But due to the irregular arrangement upon breaking, means that doesn't have any shining surface. Then as if the arrangement of the particles are quite regular, means equidistance means the enthalpy of fusion is going to be same. But there is no definite enthalpy of fusion with respect to amorphous solids. And finally, due to the regular arrangement, if I observe or if I see the arrangement of the elements, means they possess the symmetry, but there is no symmetry in case of the arrangement with respect to what solids? The amorphous solids. Okay. So this is about the which one? The distinction or the differences between the which and the which, the amorphous solids and the crystalline solids and then the amorphous solids. Okay. But as far the syllabus is concerned, or as if we are concentrating only on the regular solids or the perfect solids. Usually, which are the perfect solids here? They are the crystalline solids. Now we will have the types of only the crystalline solids, or simply they can be sometimes referred as crystals also. So here, based on the type of nature of particles, nature of which one? Particles present, and type of interactions between those particles, between what? Those particles. The crystalline solids can be of 4 types. What are those? The molecular solids are the crystals. Then we are having the ionic crystals are solids. Then we are having the covalent solids, and finally the metallic solids. It's based on what? What are the particles present in this, and what type of interactions are the net interactive force existing between those different particles. We can have the 4 different types of crystalline solids, which can be called as molecular crystals, ionic crystals, covalent crystals, and then the metallic crystals. Why they are particularly called as crystallines? Means we are concentrating only on the regular arrangement of the particles, but not the irregular arrangement of the particles in the case of the amorphous. That is why instead of the solids I can put this also. What is that? Crystals. Molecular crystals, ionic crystals, covalent crystals, and then the, which one? The metallic crystals. Okay. So the details of these different 4 types of which one? The crystals, that we will discuss in the next session. Before that, so these are further classified under 3 different categories called as non-polar molecular crystals, polar molecular crystals, hydrogen bonded molecular crystals. Again, the molecular crystals are further classified under 3 different categories called as non-polar molecular crystals, then polar molecular crystals, followed by the last one, hydrogen bonded molecular crystals. Okay. So the details of all those different 4 different types of crystals along with the respective examples that we will discuss in the next session of this particular chapter, that is called as which one? The solid state. Okay. So thank you.